Hello everyone, welcome to our video on deep exogenous and endogenous influence combination for social chatter intensity prediction. Let's begin by determining what is meant by chatter intensity in the first place. In layman terms, chatter intensity is basically how many people have interacted or will interact with a given post. For online platforms, chatter intensity determines the extent of user engagement for a given post from the time it was posted up until now. Since we want to be able to predict the virality of the post as early as possible and maybe help in curbing the spread of malicious information, we want to be able to determine this chatter as early as possible. This chatter intensity prediction has various applications in the field of ad campaigns, opinion mining, and understanding the user behavior in general. While it is well known that the user behavior as well as the discourse on a platform is underpinned by the events happening outside of the platform, very few information models actually capture this exogenous influence. Let's take the example of two subreddits from the Reddit platform, which is the Narco subreddit and the God Particle subreddit. Here we observe that as and when new season of Narcos arrive, the discussion on that particular subreddit spikes as well. Similarly, for the scientific subreddit that remains fairly, the discussion on which remains fairly consistent sees an abrupt spike in discourse at the time of discovery of the Higgs boson and its decay. While it is well established that exogenous influence have an impact on the discourse, the exogenous signals do not impact all of the subreddits equally. In other terms, a given exogenous signal or a given external event may not trigger the same response for different groups of users. As it can be seen from the example of the theme of Black Mirror, that the subreddit dedicated to Black Mirror sees a seasonal spike as and when new releases for this series arrive. However, the same one-to-one mapping is not available for the conspiracy and Ask Reddit subreddits, even though they have considerable spikes in their discourse. It can be thus said that it is a combination of the external and the internal signals that help determine the discourse on a given subreddit or the platform as a whole. Despite being able to establish this influence and the importance of it, we see that very few existing chatter intensity prediction frameworks actually capture this information. Rather, the current state of prediction frameworks rely heavily on the underlying user network, trying to determine how far a chatter will spread based on who is spreading it in the first place. While such a modeling can work well for platforms like Twitter or Facebook, where the inter-user influence can be easily established, for a majority of online platforms, this information regarding underlying user network is not readily available. Reddit being one such platform. In addition, these existing frameworks need to observe the chatter for a considerable period of time before they can start making useful predictions. This goes against the very nature of early detection of chatter for chatter intensity prediction. Inspired by the existing research and the drawbacks in it, we went on to determine the total number of comments that a post on Reddit can receive. For our use case, the comment size becomes the chatter intensity. Now, the data around the discourse and the subreddit mapping is easily available from Reddit. However, the underlying user network of who follows whom is not publicly available. In absence of such critical information, we rely solely upon the use and influence of exogenous and endogenous signals to be able to determine how and how much the user are going to engage with a given post. In absence of the inter-user influence, we have to rely upon the common state of users where the users are constantly where the current state of affair of the user is constantly updated by the incoming exogenous and endogenous signals, and upon the arrival of a new post the user is thus able to determine whether or not he or she will participate in the discourse or not. Adding a comment to the discourse can further improve the current state of affair for other users to consider whether they want to participate in the discourse or not. This cycle of read and react continues as the discourse evolves. It should be noted that in the case of zero shot prediction, the comment history is not available. Now, it will be again emphasized that for the current model, we do not have the underlying social network and we rely exclusively upon the exogenous and endogenous signals to drive the state of user to determine whether they will comment or not. However, we are not making this prediction at an individual user level, rather doing it for the discourse as a whole. We combine all of these features into our proposed framework, the ChatterNet. Let's dive into our proposed framework, the ChatterNet. For the purpose of our experiment, news articles and Reddit submissions act as a source of exogenous and endogenous signals, respectively. Each word of the text blob from the news articles as well as Reddit submissions is converted into a fixed dimension vector obtained from the word embedding layer, which is pre-trained and fine-tuned for our dataset. These vectors are then input to a one-dimension convolution block consisting of kernels of varying context size. The text embedding so obtained is used in generating the exogenous and endogenous representation for the given time interval. These intermediate representations are actually obtained as the output of the stateful GRU layer. It should be noted that up until now, two sets of CNNs in GRU are used, one each to map the exogenous and the endogenous signals respectively. This is done to be able to effectively capture the variations in the temporal as well as textual patterns of the news articles across the web versus the post on the Reddit platform. However, at the time of arrival of a new post, whose chatter we want to predict, all the exogenous and endogenous signals up till that point are concatenated to form a unified historical influence. Since different posts can arrive at different time and can belong to different subreddits, the overall contextual information associated with an incoming post can vary. To be able to effectively capture this variation in contextual information, we make use of the time evolving convolution block. The architecture of the time evolving convolution is same as that of the one dimension convolution discussed previously, with the major difference being that the kernel of the time evolving convolution block is subject to or is a function of the subreddit to which the post belongs, as well as the historical influence associated with the post. The output of this convolution block, when normalized using the using the average commenting rate for the given subreddit, then we obtain the base chatter intensity score for the given incoming post. Since all of this computation happens just at the time of arrival of a new post, the base chatter intensity score is effectively our prediction for the zero-shot task. It should be noted that this base chatter intensity can be further used to make predictions over the early observation window as well. Here again, to be able to effectively capture the variation in the commenting rate within the time window, we bin this window into multiple units. For each of the m unit, mapping the commenting rate to be the total number of comments within that bin. Now, this coarse grain commenting history is aggregated using a single LSTM here, the output of which gives us the predicted chatter at the end of the observation, starting with the base intensity that we predicted in the first place. It can be seen that the better the model gets at capturing the exogenous and endogenous influence associated with a given post, the better its performance will be for the case of zero-shot learning. And subsequently, the better its performance will be for any prediction window after the initial point. Now let's talk about some of the results we obtained from our proposed model. To begin with, we make use of 43 subreddits for the month of October and November 2019, using them as training and testing data respectively. In addition, the news articles for the month of October and November were crawled from the web. Now, we see that for this given data, ChatterNet at zero shot performs as well as the existing baseline with 1 hour of observation window. In addition, we see that models that rely heavily on the underlying pure influence perform extremely poorly when modeled on a network that is ill-defined. Thus, we can safely say that even in absence of an underlying user network, ChatterNet combines the exogenous and endogenous signals to act as a source of latent influence for the incoming post. This gives the incoming post enough context and helps the model overcome the cold start problem of zero-shot learning. To further corroborate our hypothesis of combining the exogenous and endogenous signals, we perform extensive ablation study across various variants of ChatterNet. Here again, no points for guessing that ChatterNet with the combined exogenous and endogenous signals performs best and gives the highest value for Kendall tau. However, at the extreme end, we have the ChatterNet that does not make use of either the external or the external influence. This ChatterNet static relies solely upon the textual feature associated with the incoming post. Similarly, the LSTM-CC, in addition to the textual feature of the post, takes into account the commenting count. However, both of these two models making use of only the textual feature of a post play with very little contextual information and therefore perform poorly. And in between these two extremes, we have the ChatterNet that takes into account only one signal at a time. And it can be seen that the ChatterNet with the exogenous signals and the endogenous signals perform equally well or equally bad, if you may say. However, the ChatterNet with the endogenous signals performs slightly better than the ChatterNet with exogenous signals. However, this cannot be said to be uniform across whole of the Reddit platform and needs to be further analyzed at a subreddit basis. Interestingly, we see that again combining the exogenous and endogenous signals gives us the best performance in terms of the least mean absolute percentage error. However, for submissions like Reddit politics or news, the exogenous signals tend to have greater influence than their endogenous counterpart. Similarly, for subreddits like Ask Subreddit, the endogenous signals tend to have stronger influence than their exogenous counterpart. Hence, depending on the nature of the subreddit, The subreddit may be inclined towards influence from the external or internal signals. However, it is only the combination of these two that again gives us the best or the most effective performance. Another interesting observation we made when on the x-axis we have the log of the length of the discussion and on the y-axis we have the absolute error. Here we see that for larger observations, the prediction error increases. This happens because larger discussions are rare in the real world and therefore difficult for model to learn for. Subsequently, we see that as the observation time increases, the error rate reduces, and the maximum jump in the reduction in error is obtained for the observation window of 15 minutes. Detailed analysis about all of these observations and ablations for each of the 43 subreddits is present in the paper. You can check out this GitHub link for more details about the paper as well as our framework. For more interesting research, you can also follow us on Twitter. Thank you.